All right, perfect. Thank you, everybody, for joining us. Welcome to the 2025 DME webinar series with Exaflow. This is our last webinar of the year before we take a break for the holidays. So I want to thank you and wish everyone a happy holiday season as we start. Some housekeeping rules before we begin the presentation. First, I'm 𝗦𝗔𝗩𝗘, Marketing Manager at DME. If you have questions for Wilfried in the for the webinar, please put them in the chat and we will get to them at the end of the presentation. I will be sending out some links as well in the chat, just some product brochures that we have, some where you could follow us on social media, and some other kind of goodies in there as well. As now we are going to have a webinar over about the Ringelflow cashew gate insert from Exaflow. We have Wilfried Renkel right now, and I will turn the floor over to you. Thank you.
Okay, thank you very much, Mark. Good morning to America. So we are here 6 hours ahead. So we have now 4 o'clock in the afternoon in Germany. And thank you so much to take your time and to have a look at our presentation. So and also many thanks for the good cooperation with the whole DME team. So we are talking about curved tunnel gates, formed to perfection. Here you see some pictures, how they look inside of a mold. But first, I would like to say who we are. So we are a small office, a small company with 5 employees. Our office is close to, near to Frankfurt am Main in Germany, about 50 kilometers. That's very good to travel because the airport is close to our office. So we have been around since 1999, so for 26 years. And we are specialized in curved tunnel gate inserts. These are developed by us, manufactured through production partners and distributed worldwide in approximately 30 countries. I'm sorry, my English is not so the very best. I hope you can understand me. And we handle here the technical support and sales, and also to work with our distribution partners. Curved tunnel gate inserts, that's such a name, and what terms are you familiar with? So in Germany we have a lot of, also the cashew gate here is popular, the hook gate from the Captain Hook, banana gate, 𝗦𝗔𝗩𝗘 gate because of the horn, and saber-toothed tiger gate. So there are, I'm sure, many more. So how it started? We started to cut a piece of steel. Here in this example, it was a round one. And we manufactured a EDM electrode. As you can see here, it was wire EDM'd, and later on it was CNC milled from two sides. And there was a second electrode for round edges, this here, and to make smooth edges. So it was milled, turned, drilled, thread, hardened, ground, and at the end the curved tunnel was eroded per z-axis EDM. The difference between later we switched to MEM, metal injection molding, is about 3 to 4 times in pricing. So such a produced insert costs about 1,000 euros, and in our catalog it's about less than 200 euros the price. So this was our first mold produced in end of year 2000 with a hydraulic cylinder. And let's have a closer look. This here is the insert, the slider, the rotating slider to produce the curved tunnel. Then we have here exchangeable inserts for different sizes, and this all is a assembly with many pieces. And here this is a slider to bring the radius so that we have a soft transition between where the gate is and where the curved tunnel is. So we produced it in 2 halves because that the result are sharp edges. So, and here you can see a closer look. So the thread is also produced by MEM. And here you see this slider, and also we make there's a slider to fix the rotating slider. So the material we are working is from BASF. It's called a cutter mold 420W DIN 1.4028. It's a X20 chrome 13. It's a hard-able stainless steel for production of min parts. The hardness is 50 to 5 HRC Rockwell, and the density is 7.6 gram centimeter 3. High wear resistant, and here we see this is the granulat, the compound, and this is from a German min expert web page. So fabrication in just 4 steps, and here we see it in detail. So first, the feedstock compounding. It's the granulate. It's produced by BASF, and so you buy it. The next is you need an injection molding machine and a mold. So every piece, every item from Exaflow has its mold, and during the injection molding process, we produce the cream part. Interesting is that the cream part is 22% bigger in size. That's the shrinkage. After it's molded, the cream part, we put it in an oven. It's a debinding oven, a debinding process. It's a chemical catalytic process. So the granulate includes 80% metal powder and 20% binder. 10% is wax, and 10% they do not tell us what it is in. But during the sintering, the debinding process and the sintering press the process, then it shrinks 22%. The tolerances are tight, and if you have a look here and we look dimensions 15 to 30 millimeter, the tolerance is 0.15 millimeter plus minus. So this means the curved tunnel inside then is in this precision. This is what you need. You need an injection molding machine. You need a chemical catalytic debinding oven and a sinter oven. This equipment costs about 700–800,000 euros. This is a product overview for what products we have in our program, but today we are focused on the Ringelflow, on this product. But we have other products. Here on the top you see all products we can contour-able types, but we have also here very small piece and standard flow in round and in square versions or rectangular versions. They all have names because these products are like our children. I'm proud of them. They make a great job. They help the designers, the molders, and to produce perfect parts. And we integrated clever ideas that you can produce high quality plastic parts with our inserts. So today we are focusing on the Ringleflow GRF5, this is the name for it, and placing it in the product spotlight because it's great. So here now you can see it. The dimensions are 20 to 8 millimeter here in the rectangle, and the height is 23 millimeters. It's grinded, it's hardened, and one very important thing is this here. There's a sphere geometry in the gate area, and its diameter 2 millimeter. And the customer can contour it on this sphere shape. This is a typical installation dimension for the Ringelflow inside of the mold. And you see here, this is the product itself. Then a screw to fix it. And this is where the plastic comes in. Here we need 2 ejectors, one main ejector and one support ejector, and everything has to be without sharp edges. So rounds are very important. Everything has to be smooth. So here we see an animation to show you how it works. So the plastic comes from here. Fills the main ejector and flows through the runner. And then it fills the part as a 3/4 circle from inside, from the rear side of the plastic part. That's a clever thing. We have many customers, they produce children toys, plastic parts toys, and children took it in the mouth, so they cannot damage the mouth. Electrical parts, they have no overstand, and so if you assemble with other plastic parts, big benefit. But in the presentation, I will show you more than this benefit. And here now the decading, and so you see what's the sense of the second ejector. So here it's horizontal with the 2 ejectors, and the point where it bent is this support ejector. That is very important. And so we give the dimensions the customer needs on the hand. It's on the web page, it's on the product page, and it's really working. And so you can produce nice products. This animation shows what is going on if there is no support ejector. So we had one customer forget to install the support ejector, and this was the result. It really hit the runner, really hit the plastic part and damaged it. But was no problem, there was no cooling hole, so customer was able to add the support ejector at this position. So that's not a good idea. So if you forget to install the support ejector, okay. So what is the difference between our standard flows and the Ringelflow? With the standard flow inserts, and here we see one also very popular product from us, the GTK contour flow we called. So here is where the runner and the part separates automatically during the ejection. So we have a tear down. If the gate size is big, let's say 2.5 or 3 millimeters, and the wall thickness from the plastic part is thin, sometimes it can be that you need 2 ejectors here and here, that you have no braking lines, no wide breakage, breakage, what you can see on the plastic part. And with the Ringelflow, we shear the runner from the plastic part. So here is a shearing process, and this needs less force to shear, and the one benefit is also that you can increase the size. So if you have a heavy part in weight, and so with the Ringelflow, there is the advantage that you can increase the gate itself, the diameter. Okay, now I will show you some things in my CAD system. So, as I told before, there's a sphere here in this shape. It's a section here, you see, and if I unhide it, so you see the real Ringelflow, and the red thing you see is a sphere. If you cut a sphere, the result is a perfect circle. Perfect circle is good because the hot sole is in the center, and on the outer surface it cools down. So I'm working on a system that is parametric, and designers like that we can use a parametric sketch on this system. Here you see the diameter 2 millimeter. Here we have an angle from 5 degrees, and this dimension here, let's make it smaller to 1 millimeter. And then it change. Oh, 1, okay. And go back to 1.5, 1.6, it doesn't matter, 1.5. Okay, so the part I created here is such a housing, and the red thing we see is headwater stream or frontal flow. This is what every molder, every injection molder like to have. So the plastic comes from here, it hit the opposite face, and then it builds like a pancake. And the pancake then relaxes the structure of the plastic, and so there is no way for free jet formation, and that is a perfect solution. Let's see this slice here. Yeah. So customer has to mill or to wire EDM, this shape, and the runner itself. The runner has to be greater than the curved tunnel itself, and what is very important is fillet, a good fillet. Here we have 2 millimeter fillet. So this is one example to show what the designer can do. So this here is a real thing from customer, and sometimes it's not allowed to show the real plastic part, but a piece of it is okay. So here you see where the parting plane is. It's here where the highest position of this radius is, and we inject here, and as you can see, a greater size of diameter. So here is a big wall thickness we inject here, and so the big thickness help us to fill the part. Here is a long part, and it's a bit similar to fill here. This here was a self-made solution from a customer, and he filled to the high wall, and the result was jetting. So we put our Ringelflow in. We added the 2 ejector, the support ejector, and the main ejector, and the result was a perfect plastic part with high surface finish. So this is, we often have, so a top part and the upper part. And it's interesting to see the shape here. So there is the parting plane, the runner, the rounds. And here is interesting to fill where the rib is. So the rib also helps us to fill the part. It's like a flow helper. Not sure how you say it in English. In Germany, we say it's a flow helper. So if you have a thicker wall thickness and you can inject there, it's better to fill the part. Okay, here, this is important. If you have an angled parting plane. So I recommend to make a transition from the ankle surface to a flat horizontal face. And then it's more easy to degate, to have a perfect runner, to have a fillet inside. And here we have a two cavity mold in opposite. And it was a nice project for the customer, but forbidden for us to show the real thing. This was a project with DME, and not so easy to inject from here because there's the rib shape, and if you inject here in the high wall, it could be that checking also could be a problem. But with Ringelflow, it was really nice to find a solution for it. Okay. So let's continue. This is what we want, frontal flow. Let's start the animation. So plastic comes from here, hit this surface, and then like a pancake, it fills the whole part. Don't know if this works, these terms are right. Headwater stream or frontal flow, and this we have with the Ringelflow. And this is the opposite. We don't like jetting. It comes like a sausage inside, and then you can see it on the surface. It's a defect. It's not good for plastic parts. Okay, here we have a door ring for a washing machine, industrial washing machine, 16 millimeter in diameter. And so let's have a look at this video. So not so easy to make a movie ad with all the, but here you can see the chatting formation. And that was not accepted by the end customer. We had many of these chatting formations on this ring. So 10 pieces of Ringelflow was distributed around the circumference. Here, wow, you can see the chatting lines. It's like in a book, you explain the phenomenon of chatting lines. Here, also inside. Can you see this? Oh my God. Here, now you see it like a sausage. So let's have a look now to see where customer injected. Here now we can see. So let's pause. He injected here and then the plastic can go through the high wall, and this is the reason. And it's orientate. The orientation is in this direction. That's the reason we see the jetting in this direction and also on this curved surface. Okay. Yes, this is now the solution. So we placed 10 pieces of Ringelflow, and this solved the problem totally. So, perfect surface. Like piano painted. Not really, not really, but it was good enough for an industrial washing machine, 60 centimeter diameter. And here you can see where we injected with the Ringelflow. And we have so many samples with very happy customers because we solved this problem. It worked like a charm. That's a good example. I like it so much. Okay, two different parts, one with the checking problem and the other one with the solution Ringelflow, and checking was totally solved. This is also a great idea for the Ringelflow. If you have two component molds with a hard plastic and with a soft plastic outside, maybe rubber-like, TPE or TPUs. So you can inject through a hole, maybe produced by a slider, just a hole slider. So and so you inject from inside, from the rear side, through the hole to the soft component. Great. And drilling machines, hand drilling machines, and so on, and toothbrushes, and so on. So many parts are produced using the Ringelflow for 2K component. So what also is a great idea is to produce overflows in plastic. Yes, in a plastic injection mold. So I know this from casting. And here on the right side, this picture is casting. So here we inject the casting, maybe aluminum or something else, or zinc. And what we here see, these are all overflows. I remember many customer problems with silver streaks. So if there is a silver powder inside of the plaster or of the plastic to make it look like metal, and where the plastic flow, you see then the silver streaks. And with the overflows, you can make a direction where this material goes. It also helps to avoid flow lines and burners. So then you do not have only to inject the plastic in one Ringleflow. At the end of the part, you can produce overflows or add overflows to solve such problems. Here we see a brittle plastic type. It's an ABS 𝗦𝗪𝗪 blend 𝗬𝗢𝗪, and the white shiny spots here is that 10% more than it will break, but we see only these shiny spots, but it works. It never breaks, and so 100% sure safe production. And as you can see, if the plastic is brittle, you can have such a result. Okay, I have some more videos. Let me show you here. So here we see a chrome ring. Many chromed or electroplated parts customers are fans from our Ringelflow. So the surface is perfect, and we inject from the rear side of the plastic part. In the mirror you can see me and and the camera. So this is the plastic part, unchromed, just as it comes out from the machine. And the gate position is, camera was not so very good, but in the chrome part it was good to see. Here, here, okay, yeah, here is the gate point. Here is the gate point with the Ringelflow. Okay. And another part is here. The customer installed from the bottom an insert, and self-made in 2 halves produced insert, and jetting was a problem here. Just a moment. Okay. Here you see, here injected in the high wall. Why? Then the result was a bad plastic part. Okay. And now a perfect part, perfect surface. What a difference. To avoid jetting, find the right way where to inject. Here inside is the point, the gate point from the Ringelflow. And you can see how clean it splits from the runner, the curved tunnel, from the part. I hope you like it also. Here the black part injected here into the high wall, and the good part injected here, and to produce this head water stream on the opposite side. This is a self-made Ringelflow from a customer. He scaled it in bigger, and you can see here this not so nice, the parting plane is not so good. If you produce it into two halves, it could be that you have flush. Is the name flush? I guess it's flush. And it's a talcum mineral filler part, and you see that here is a breaking line. So that is the reason I like to recommend which plastic types are working with the Ringelflow. So we have to look in the data sheet for the mechanical properties. And so the modulus of elasticity, the Young's modulus, up to 2,500 megapascal, not greater, not more. Elongation at break, 40% or better, 50% or higher, and elongation in bending, 50% or higher. So we need a bend-able plastic. So 3 years ago, a customer from Italy had some projects, many molds, I guess 12 different molds, 12 different plastic parts for the electro car, Tesla and so on industry. The plastic was a Reamax with 30% glass fiber and also a powder ingredients that it cannot burn. And from the specs of the plastic, the mechanical properties, we thought it cannot work. But then we did a test. Customer, the support team from the plastic manufacturer supported us to make a test on an injection molding machine. The product was this here, and it worked. So sometimes you cannot really trust the data sheet from plastic suppliers. So take the shrinkage. They say if you have a plastic part 300 millimeters long and you have to produce it tolerancing 1/10 of a millimeter, and they say you have a shrinkage between 0.5 to 1.5, and you have to produce such a precise plastic part. So you wish that the plastic supplier gives more precise information to you. So this is the viscosity, the table of viscosity. If you need an idea for the gate itself, and we have low viscosities, that's PA, PE, polycarbonate, polypropylene, and so on. Medium viscosity, ABS, ASA, polystyrol, and so on, and high viscosity, mostly the high material plastics like PEI, like PSI, PSU, PPS, and PC, PBT, and so on. And so let's say we have a medium viscosity plastic part in ASA, and the weight is 35 gram. So you look here, 35 to the red line. So the gate is maybe 1.7, 1.88 millimeters. For larger parts or more heavy parts, there is also a table of viscosity we see here. So this is for you, from us, to have an idea how to inject with which gate diameter. So here is a video to explain distance L and AT. Here we see a standard flow, but it's the same system for the Ringelflow also. Okay, you install or assemble the tunnel gate, you fix it with a screw. Very important, no sharp edges, good rounds everywhere. The ejector depth and the length is very important. So we give you an idea for this. We have charts. Okay, and here you see how to contour. This is our GTK contour flow, but it could be the same with the Ringelflow. So if you download the cut files from the DME webpage or from Exaflow webpage, you have the point you like to inject. You have the same point in the Exaflow insert. And place the contour flow reference point on the gating point. Transfer the parting plane of the plastic molding to the contour flow insert. Rework the runner. Machine the gate. And then it should look like this. And here you see also here to inject frontal flow or head water stream. This gives good results. And then you have a clean degating point without projection. So let's have a look on our web page. This is the Exaflow web page, and here we have the products. Let's have a look here for the Ringelflow. You see the dimensions, the material, the hardness, 52 to 55, the HRC Rockwell. Here this table of viscosities, installation, for TPE, the recommendation. So there is an inquiry. If you have inquiries, so you can fill it out. You can place your files. Maximum size is 10 megabyte, and we prefer step AP 214 or 242. And here on the download page, you have the catalogs, product sheets, and so on. And also download, you can the cut data you can download from our webpage, from Exaflow, but I'm sure you can also download from DME, from the DME webpage. Okay, I'm ready with the presentation, and thank you very much to listen me and to take your time. And now Mark is there to help you on how to use the DME webpage to download cut files and maybe make inquiries. And we both are here for your questions.
Absolutely. Thank you, Wilfried. We have a lot of questions, so we're going to jump into that right now. This presentation was amazing. It's great. Also, customer interaction is perfect. So if you guys have any other questions, please send them in the chat. We are ready to go for this. First question we have in here is, using the Ringleflow gate insert, are there any visible marks or blemishes on the part, or is the gate area a clean break?
It depends. It's not only the gate itself to produce perfect surfaces. It's also a thing of cooling. So if you inject through a hole to a plastic part, we have a bit the thing, it's like you took a burner, and with this burner you heat up the opposite part of steel, and temperature is mostly a problem. So temperature and as well air. You have to move out air. So that's not part of this, I'm sorry, of this presentation now, but we worked with companies. They are specialized in closed contour cooling. So mostly this are produced by, what is it, soldering inserts, or laser powder sintering. And I learned a lot from them to produce piano colored plastic parts. But the Ringelflow is a very good solution for perfect surfaces, but it's not the only thing. So the molder itself is very important, what parameter he uses on the injection machine. So there is also a profile, a stepped profile he can use during injection. So we say inject slow, then fast, then faster. So there is no way for the heat, so you can bring the heat away from a spot. And all these things are important. It's not only Exaflow, it's a clear picture, it's a puzzle, and if everything is okay, then you can produce perfect plastic parts. But we have so many years of experience. If you have a case, you need such a plastic part, ask us and we will help you. We will support you, and our products are one big key to produce perfect plastic parts, but let's say 60–70%, and the rest of 30% is on the team of designers and mold makers, and also the people on the injection molding machine.
Awesome, thank you. The second question we have, for this gate insert, is there a standard or recommended runner diameter? Also, could you advise on the appropriate runner size and cross-section profile to achieve optimal flow? So the first question, is there a standard or recommended runner diameter?
Yes, it's not standard, because we sell a piece of steel it's hardened, it's grinded in high precision, and the curved tunnel is in. It's like an ejector in 250 millimeter length, and the mold maker has to shorten it for the length he needs at the end. And here you have to contour it, and here you have to bring in the runner. And for the Ringelflow, the runner diameter is 5 millimeters.
Okay, and then okay, so the appropriate runner size and cross-section profile to achieve the optimum flow. Shall we hit that or?
So we recommend for each product we have in our program, we recommend the runner diameter. What is the best for?
Okay.
For the standard products, so was not part of the presentation today, they have the runner included.
Okay. I think you already answered this in the presentation, but I think it's worth mentioning again. Does this gating cause a jetting or blush on here?
Can you say?
Does this gating cause jetting on here? So there's no jetting, correct?
With the Ringleflow and with the right position to inject, there is no jetting. But it's to find the position. So I explained this Ringelflow diameter. First, the customer that decision was to inject from the bottom, and there was a high wall. So that's a perfect example for to do not. So because the result is jetting, and we changed the design with the Ringelflow, and then it was totally solved. There was no jetting because physically it was impossible to have the jetting effect. And so also we make technical support. I guess a very high level of technical support because of me, because of our team, because of many years of experience. So if we know what you need with your plastic part, so we can support you. And I look not only for the for how to inject. Sometimes I have plastic parts and I see features on the plastic part, and I guess what's here with this shape? They need a slider. They have no slider inside of the plastic part, and then I have the whole piece of the plastic and how to build the mold and how to inject, and so we help. We will help in this case. So ask us, please send your technical inquiry, the best with the plastic type, which plastic type, with the data sheet from the plastic manufacturer. If you have an idea where you like to inject, so please tell us, make a sketch or a picture or something else, and so we find a solution for you and for your plastic part.
Awesome. And again, DME representatives are also willing to work with you and get you in touch with Wilfried so we can hammer out those problems and get you going.
Yeah. Perfect. So many times.
Absolutely.
Yeah.
It's what plastic materials can be used in this style of gates?
With the Ringelflow.
Yep.
I explained it with the specs, the mechanical properties. So we need the, what is the English name for it? In Germany, it's 𝗦𝗦𝗦. Just a moment, I have the word here in the presentation.
Well, we can answer it afterwards, and we can just go to the next one.
Yeah. Okay.
Okay. And we'll get to that one. The person we have, the person who answered that question. Can you use a glass filler with these inserts?
It depends. We have to look for the data sheet of the plastic part. So if we have 10% or 15%, it could work, but we have to look how bend-able the plastic is.
Okay. 2 more questions we have. If anybody else has any questions, please put them in, but we got 2 more. Are there shot size limits?
Yes. So we have a house number. For each gate, you can inject about 250 grams with one gate, but it depends on the flowability of the plastic, which plastic you have. And we can also inject 250 grams. So if you have a plastic type, a plastic part with 1 kilogram on weight, so you have to place 4 inserts, 4 gates. I guess all people are involved in designing molds and injection molding, then it doesn't matter if it's a hot nozzle or other different gates. So this is the house number. We have to look how many holes are inside, or how many ribs are inside, or domes, or something else. It's not so easy to make a chart and say this is the thing and this is the thing. We need our experience and look for it. But I know the house number 250 gram to fill with 1 insert, and flow pass 250 millimeter length mostly worked very good.
Okay. And last question, which I already know the answer, is can you help with runner placement in my design? And the answer is yes. DME and Exaflow will definitely be able to help you out with any of your needs on that one. So
yes.
So yeah, just get a hold of your DME rep and let us know what you're looking at, and then we can get Wilfried and his team here, and we'll get that done. So that was the last question we do have. Again, Wilfried, I want to thank you. This is an amazing presentation. We will be sending out a copy of this, so everyone, if you if you want to go back and listen to the presentation again, we'll be sending that. It'll probably be within a couple days or so. We'll give you those questions that we can answer. We'll send that out to you, and we'll also send you a few goodies too along with that email. Other than that, I just want to wish everyone a happy holidays. We will be taking a break next month with our DME webinar series, but we will be back in January. So stay tuned for that. Once again, thank you, everybody, and we will see you next year.
Thank you. Bye-bye. Have a good day. Have a good time.
And webinar is ended. Good job.
Okay.